Okay, so in this session, we will start with a topic called log or logarithm. Okay. To understand log, we need to understand indices, index, power. Okay. Say for example, if I have 2 raised to the power 5, we know the value of this is equal to 32. So 2 to the power 5 value is equal to 32. Now, what is the meaning of log? In short, this logarithm is called logs. Alright, how do we express it? So log is a function which tells us that a given number is what power of another given number. So in this case, 32 is which power of 2. So if I write it like this, 32 is which power of 2. For this question, the answer is 5. Alright. Now, for this whole process, there is one single expression. So this statement can also be written in the form of log, and it is like this: log of 32 to the base 2. So this statement is written here. So log of 32 to the base 2 is equal to 5. So we say because 32 is 2 raised to the power 5, we say log of 32 to the base 2 is equal to 5. So this expression defines log. Alright. So how is it read? It is read as log of 32 to the base 2. Log of 32 to the base 2 is equal to 5. Alright. Now let's define it theoretically. So theoretically we can say that if we have a number a to the power x is equal to n, then log of n to the base a is equal to x. So n is the number, a is the base, x is the power. So if this is true, if a raised to the power x is equal to n, then log of n to the base a has to be equal to x. And if this is true, log of n to the base a is equal to x, then n is equal to a raised to the power x. So let's take some examples. If I have log of 81 to the base 3, how much is it equal to? It's a very simple thing. You think about the powers of 3. Now what are the powers of 3? 3 raised to the power 1 is equal to 3. 3 raised to the power 2 is equal to 9. 3 raised to the power 3 is equal to 27. 3 raised to the power 4 is equal to 81. Right? So 81 is 3 to the power 4. So we say log of 81 to the base 3 is equal to 4. This is how logs are defined. Okay, we'll take some more example to understand this. Now let's suppose we have log of 8 to the base 2 is equal to. So what you have to think is, what power of 2 is equal to 8? What power of 2 is equal to 8? So 8 is 2 to the power 3. So log of 8 to the base 2 is 3. Let's say log of 25 to the base 5. What do you have to think? 25 is what power of 5? So 25 is 5 square. So log of 25 to the base 5 is 2. Let's take some more examples. Log of 27 to the base 3, how much is it? So think about the powers of 3. 3 to the power 3 is 27. So log of 27 to the base 3 is equal to 3. Alright. Let's take some more examples. If I say log of 625 to the base 25. Now, so 625, we know it is 25 square. Hence, it is equal to 2. But if it was log of 625 to the base 5. So which power of 5 is 625? It is 5 raised to the power 4. So log of 625 to the base 5 is equal to 4. Let's take log of 81 to the base 9. So 9 square, we know it is 81. 9 to the power 2 is 81. So log of 81 to the base 9 is equal to 2. Suppose we have log of 128 to the base 2 is equal to. So if you read the powers of 2, it is 2, 4, 8, 16, 32, 64 and then 128. So 128 is the 7th power of 2. So 1, 2, 3, 4, 5, 6, 7. 2 to the power 7 is equal to 128. So log of 128 to the base 2 has to be 7. Alright. Now let's take some different examples. Now, what about log of 3 to the base 9? So what power of 9 is 3? Okay, we know that 3 square is equal to 9. That means 3 is equal to square root of 9. Now square root in terms of power, it is written as power half. So it is 9 to the power half. So we say 9 to the power 1 by 2 is equal to 3. So log of 3 to the base 9 is equal to half. What do you have to think? 3 is which power of 9? Right? 9 to the power what is equal to 3? So that is equal to 1 by 2. So answer of this is 1 by 2. Let's take another one. If I have log of 2 to the base 8. Now we know that 2 to the power 3 is equal to 8. That means 2 is equal to cube root of 8. And cube root of 8 in terms of power is written as 8 to the power 1 by 3. So log of 2 to the base 8 will be equal to 1 by 3. Alright. So there can be some fraction powers also. Now there can be some negative powers also. Suppose we have log of 1 by 2 to the base 2. How much is this? Now how do we do this? Let's see. We know 2 to the power 1 is equal to 2. We know 2 to the power minus 1 is equal to 1 by 2. Alright. And we have to find log of 1 by 2 to the base 2. Now 1 by 2 to the base 2, that will be equal to minus 1. So the power is minus 1. Let's take another one. Suppose we have log of 1 by 9 to the base 9. So what power of this base 9 is equal to 1 by 9? So we know it is, we can write this as, this 1 by 9 is written as 9 to the power minus 1 to the base 9. So 9 to the power minus 1, that is equal to 9. So it is minus 1. Let's take. So now if you have understood the basic meaning of log, let's understand the rules of log. Now let's try to learn the rules of log. The first rule, rule 1, it is also called the rule of power. Let's see what it means. The rule says that if I have something like log of a to the power x to the base b, then this power x comes outside. Everything remains as it is, just this power x comes outside. So we can write this as x log a to the base b. That's it. So x log a to the base b. Similarly, if there is a base which has some power, so let's say log of a to the base b to the power y. So what will happen? Even this power y, even if it is the power of base, it can come outside. But when it comes outside, it comes in denominator. So this can be written as 1 by y log a to the base b. Now suppose both the number as well as the base have some power. So we can write them as, let's say, log of a to the power x to the base b to the power y. So here the number itself is a to the power x and the base itself is b to the power y. So both the powers x and y will come outside. Just remember, the power in the number will come in numerator, power in the base will come in denominator. So this becomes x by y log a to the base b. So this is the first rule. Let's take some examples, some more complicated examples. If I have log 1 by 9 to the base 3, we have done this earlier also? No, we haven't done this earlier. So let's take this one. Log of 1 by 9 to the base 3. How can we do it? Let's try to see that this 9 is 3 square. So we can write it as log 1 by 3 square to the base 3. Now something in denominator, when it goes in numerator, the power becomes negative. So we can say it is log of 3 to the power minus 2 to the base 3. Now whatever is the power here is minus 2. So minus 2 will come outside. So it is minus 2 log of 3 to the base 3. Now 3 is what power of 3? Now any number for itself it is power 1. So it is log 3 to the base 3 is 1. So we can say it is minus 2 into 1. The final answer will be minus 2. Alright. Now let's take the next example. Suppose we have log of 8 to the base 4. Now what is this equal to? Now here 8 is not the direct power of 4. But both 8 and 4 are powers of 2. So we can say it is log of 8 can be written as 2 to the power 3. 4 can be written as 2 square. So what will happen? This power 3, and this power 2 will come outside. The numbers that I have put as star mark will come outside. So this 3 comes outside in numerator because it is in number, and this 2 because it is in base will come outside in denominator. So we will have 3 by 2 log 2 to the base 2. Now what is log 2 to the base 2? Any number to itself it is the power 1. So log 2 to the base 2 is 1. So this whole thing is 1. So final answer is just 3 by 2. Let's take another one. Suppose I have log of 125 to the base 625. Now we know that 125 is not a direct power of 625, but both of them are powers of 5. Now 125 is 5 cubed. 625 is 5 to the power 4. So from here this 3 will come outside, this 4 will come outside, and it will become 3 by 4 log 5 to the base 5. Now you see log 5 to the base 5 is 1, so the final answer is 3 by 4. So this is how rule of power can be applied in complicated situations. Even in this case, where we have, let's say, log of 2 to the base 8. Now this can be written as log of 2 to the base 8 can be written as 2 cubed. So here this base has a power 3. So this 3 will come outside and will come in denominator. So 1 by 3. There is no power in the number. So it will be log of 2 to the base 2. Now log of 2 to the base 2 is 1. So final answer will be 1 by 3. Alright, let's take another one. If I have log of 1 by 3 to the base 1 by 9. Now see, 1 by 3 can be written as 3 to the power minus 1. And this 1 by 9. 9 is 3 square. So 1 by 3 square. Hence it is 3 to the power minus 2. So what will happen? This minus 1 will come out. Minus 2 will come out in denominator. And inside we have log of 3 to the base 3. Now log of 3 to the base 3 is 1. Minus and minus cancelled. So we will have 1 by 2 as the final answer. But this rule or this process can be applied only when both the number and the base are powers of the same base or powers of the same number. Only in those cases the simplification can happen. Now, if the base and the number are not powers of the same base, then what do we do? Let's take an example. So if I have log of 9 to the base 16 and the question says simplify, then let's see what we do is we can say log of 9 can be written as 3 square. 16 is a power of 2. That can be taken as 2 raised to the power 4. So this 2 and this 4 will come out. So it will become 2 by 4, and inside we have log 3 to the base 2. Now we cannot do any simplification for log 3 to the base 2. So leave it as it is. But 2 by 4 can be simplified as 1 by 2. So the final answer will be 1 by 2 log 3 to the base 2. That's it. This is the maximum simplification that you can do in this particular situation. Now let's move on to the next rule, rule 2. It is rule of multiplication or division also. How does this work? Let's see. Suppose we have log of x into y to the base b. Now we can separate them. If we separate them, what happens? We have log of x to the base b plus log of y to the base b. So understand, the base remains same. The numbers split, right? Because here whenever there is a multiplication we get a plus sign and log is applied to both the numbers. So log of x to the base b, log of y to the base b, and they get added. So whenever there is a multiplication between the numbers, there is an addition between the logs of those numbers. Alright. So if it is, let's say, log of xyz to the base b. So we can say it is log of x to the base b plus log of y to the base b plus log of z to the base b. This is how it goes. Alright. Let's take the example of division one. Suppose we have log of x divided by y to the base b. Again they can be separated. Again there will be two logs. It's just that when there is a multiplication we have a plus sign in between logs. When there is a division between numbers there will be a minus sign between logs. So this will become log of x to the base b minus log of y to the base b. Alright. Let's take a mixed example. If I have log xy divided by z to the base b. How would you open it? If you see x into y divided by z, so wherever there is a multiplication, they will be added, and the number which comes in division will be subtracted in the log. So it will become log of x to the base b plus log of y to the base b minus log of z to the base b. Let's take some questions on them. Suppose there is a question that says simplify. One important thing, this rule that we just learned, I'll write it again, log of xy to the base b is equal to log of x to the base b plus log of y to the base b. It can be applied both ways. Alright, so if there is an addition of logs given, if the bases are same, you can multiply the numbers. Similarly, log of x upon y to the base b is equal to log of x to the base b minus log of y to the base b. This also is applicable both ways. Just that remember, when you go from this right hand side to the left hand side, the base has to be the same. Then only you can do that process. So let's take an example. Suppose we have simplified log of 25 to the base 10 plus log of 40 to the base 10. Right? Now, what do we see here? We see that there are two logs and the bases are same and there is a plus sign. So what we can do is, we can take one single log, and because there is a plus sign, the numbers inside can get multiplied. So it becomes 25 into 40. Now 25 into 40 is 1000. So log of 1000 to the base 10. Now see, 1000 is 10 to the power 3. So it becomes log of 10 to the power 3 to the base 10. Right? So this 3 comes outside. So we have 3 log 10 to the base 10, which is 1. So the final answer of this question would be 3. Suppose we have a question which says log of 25 to the base 10 plus log of 24 to the base 10 minus log of 4 to the base 10. Find value of this. And it is given that log 2 to the base 10 is 0.301 and log 3 to the base 10 is 0.477. So this data is given and you have to find the answer of the value of this expression. Now what do we do? What we can do here is, one is that we can separate all of them, or we can calculate each one of them separately and then add or subtract. Or what we can do is we can combine all of them like this. See, there is a plus sign here, so these two numbers will get multiplied. There is a minus sign here, so this number will be divided. So we will have log of 25 into 24 divided by 4 to the base 10. Now 4 cancels 24 6 times. So we have 25 into 6. So that becomes log of 150 to the base 10. Now 150 can be written as log of 150 can be written as 300 by 2. So it is log of 3 into 100 divided by 2 to the base 10. Now if you separate them, 3 into 100 divided by 2. So we will have log 3 to the base 10 plus log 100 to the base 10 minus log 2 to the base 10. This is what we are going to get. Now this becomes very easy because log 3 to the base 10, the value is already given. Remember, you will never have to memorize the value of log. You will never have to calculate the value of log from your side. The data required would be given. So that also is a hint. If something is given, you have to use it. So it becomes 0.477 plus. Now we know that 100 is 10 square. So it becomes 2. Log 100 to the base 10 is 2. Minus log 2 to the base 10 is given 0.301. So 0.477 minus 0.301 will become, the whole thing if you add subtract it will become 2.176. Alright. So 7 minus 1, 6, 7 minus 0 is 7, 4 minus 3 is 1. So final answer of this question is 2.176. So this is the second rule of log. Suppose we use the same data and it says log 2. Suppose if it is given that log 2 to the base 10 is 0.301, log 3 to the base 10 is 0.477. And the question says find the value of log 576 to the base 10. How do we do this? Let's see. Now we know that 576 is square of 24. Now if you remember the square, well and good. If you don't, then you can factorize. Let's say 576. If you factorize, if you remember the method of factorization, divide by 2, it will give you 288. Then again divide by 2, it will give you 144. Now at the same time, if you remember the table of 4, you could have directly taken out 4 or divided by 4 to get 144. Now 144 is 12 square. So 576 effectively becomes 2 into 2 into 12 square, which is 2 square into 12 square, which is 24 square. 24 itself is 8 into 3. So it is 2 cube into 3 whole square. Right? So this is the factorization of 576. So if I write it here, let's see what happens. Let's write it as log of 24 square to the base 10. I have just explained factorization as an extra thing. In this question, first of all, write 576 as 24 square. What will happen is 2, because it is a power, it will come outside. So it becomes 2 log 24 to the base 10. Right? Now this 24 is 2 cube into 3. 24 is 8 into 3. Which is eventually 2 cube into 3. So what we can do here is, we can write it as 2 log 2 cube into 3 to the base 10. So this 2 is completely outside, and inside we have these things. Now this 2 is completely outside. Inside we have log of, now you see this is 2 cube into 3. So whenever there is a multiplication, logs can be separated with a plus sign. So log 2 cube to the base 10 plus log 3 to the base 10. Alright, so we have 2 into, now from here, only from this 3 comes outside, so it is 3 into log 2 to the base 10 plus log 3 to the base 10. So now whatever values are given, you can use them here. So I'll take here, I'll write it here. So this expression comes here, and we have, this 2 is completely outside, as you can see. So it is 2 into this 3 that is already there into log 2 to the base 10 is given here, that is 0.301, and then this plus sign, so plus, and then log 3 to the base 10. Now log 3 to the base 10 is here, so it is 0.477. So you have to add them carefully, right? So it is 2 into, now 3 into 0.301 is equal to 0.903 plus 0.477. If you add, you will get 2 into 3 plus 7 is 10, 0 plus 1 plus 7 is 8, 9 plus 4 is 13, so it is 1.38. So final answer is 2 into 1.38, which is equal to 2.76. So the final answer of the question is 2.76. So log of 576 to the base 10 is 2.76. These values must be given. Alright. Now we'll move on to the next rule. It's a very important rule, that is rule 3. And here this is called rule of multiplication of logs. Earlier what we did was multiplication of numbers inside the log. Here we are talking about multiplication of log. Now how does it work? Let's see. Suppose I'll give an example. Can you say anything about log of a to the base b into log of c to the base d? No, there is no rule for this. I'm giving you all different possible situations, then we'll go back to the rule. First this one, there is no rule. Can we say anything about log a to the base b into log c to the base b? Now here there was no relation between the numbers and the bases. Here there are two logs, the bases are same. Can we say anything about them? No. Be very careful. There is a very specific situation in which the logs multiplication is possible, right? Let's take another example. If I have log a to the base b into log a to the base c. So here the bases were same, but we don't have any rule. Here the numbers are same. Do we have anything? No. Here also there is no rule. There is only one situation which is like this: log of a to the base b into log of b to the base c. Now this is a very peculiar specific situation. First note it down clearly. There must be two logs multiplied. Base of one of the logs should be the number in the other log. You remember, this is the position of number. This is the position of base. This is the position of number. This is the position of base. So base of one log should be the number in another log. Then only the multiplication is possible. And what is the outcome? The outcome is, if this is true, then the outcome is only one log, right? And one log, and in which the numbers will be other than the common number. So b was common, so b gets eliminated, and the final answer will be log of this number to this base. So it is log of a to the base c. Please note it down very carefully. This is one very beautiful rule. So logs multiplication is possible only in one case, where number in one log should be equal to the base in another log. Then only the multiplication is possible, and the number which is common is eliminated. There will be only one log in the answer with the remaining number. So the remaining number and the remaining base will come in the answer. So if I have log of 4 to the base 3 into log of 3 to the base 8, how much is it? Let's see. So here you can see this 3 and this 3 are same. So 3 and 3 gets eliminated, and the final answer will be log of 4 to the base 8. Then you can further simplify it. It is log of 2 square to the base 2 cube, which is these powers 2 and 3 will come outside. Inside we will have log 2 to the base 3, 2 to the base 2. Log 2 to the base 2 is 1. So final answer is 2 by 3. Alright. So please understand that the multiplication of logs is possible only if base in one log is same as the number in another log. Let's write down the rule here first. I'll write the rule here again. Rule is log of a to the base b into log of b to the base c is equal to log of a to. Now, if this is written here or this is written here will not matter, right? Now, from this, as you can see, if I send one of them to the other side, if I send this log b to the base c to the other side, it will be divided. So we will have log a to the base b equal to log a to the base c divided by log b to the base c, right? This is the outcome of the first rule, right? Now, how do you remember this? Let's see. If there is a log which combines a number and a base, they can be separated. How do we separate them? We introduce a third number c. Then a becomes a number in the log in numerator, b becomes a number of a log in denominator, and c becomes a base in both the places. Alright? Say for example, if there is a question like this, log 3 to the base 10. Suppose the question says log 3 to the base 10 is 0.477 and log 2 to the base 10 is 0.301. Find the value of log 3 to the base 2. How do we do it? We will follow this second rule. So here in place of a we have 3, in place of b we have 2. Alright, so log 3 to the base 2. So we introduce a third number c, and let's take c as 10, because the values of log 3 and log 2 are given in base 10. So what we write is, we take this as log 3 to the base 10 divided by log 2 to the base 10. Now these values are given. Log 3 to the, we can take any base, but here we will use that base for which the values are given. Alright. So log 3 to the base 10 is 0.477. Log 2 to the base 10 is 0.301. Right. So you can do some approximation. Now 0.4. So decimal goes away because after decimal we have 3 digits here, 3 digits here. So we can take it as 477 upon 301. We can do approximation and make this one equal to 0. So approximate answer is 1.59. This is your final answer of this question. Let's go back here. What if I have log a to the base b into log b to the base a? What will happen here? So suppose I take b as the common number and it goes away. What are we left with? We will be left with log a to the base a. Now what is log a to the base a? Log a to the base a is 1. So that means this is equal to 1. So log a to the base b into log b to the base a is equal to 1. And from here you can see that log of a to the base b is equal to, this goes to the other side, in denominator it becomes 1 by log b to the base a. So if I have to reverse, if I have to change the position of number and base, what I need to do is take them in denominator and vice versa, right? So if there is a number log in denominator, if it comes in numerator, what will happen? The number and the base will interchange. Alright. So suppose we have log of 9 to the base 8 into log of 64 to the base 27. Now here if you notice, both 9 and 27 are powers of 3, 8 and 64 are powers of 2, or maybe 8 also. So what we can do here is, let's write this as 9 as 3 square, 8 as 2 cube into 64 as 2 to the power 6 and 27 is 3 cube. Right? Now first let's apply the first rule, that is power, rule of power. This 2 and this 3 will come outside, so it becomes 2 by 3. This power comes in numerator, this 3 comes in denominator because it is in the base. We have log 3 to the base 2 into, from here this 6 and this 3 will come outside, so 6 by 3, and we have log 2 to the base 3. Now this 2 by 3 and 6 by 3, put them together, 2 by 3 into 6 by 3 into, let's put these two logs together. So we have log 3 to the base 2 into log 2 to the base 3. As you can see, this portion will become directly equal to 1. This 3 cancels 6 2 times and we have 2 into 2, 4 by 3. So the final answer is 4 by 3. Let's take another good question. Let's take another example. Suppose we have 1 by 1 plus log a to the base bc plus 1 by 1 plus log b to the base ca plus 1 by 1 plus log c to the base ab. And the question says simplify. Now let's try and solve. See, always remember, a log and a number can never be added or subtracted. This one is a number and this is a log expression, so they can never be added or subtracted. Two logs can be added, that we have seen, but there is a condition. Condition is that base should be same. Now here it is 1, here the base is BC. So what should we do? We know that log of any number to its own base is equal to 1. So this one can be written as a log of a number to its own base. Here the base is BC. So this one can be written as, log of BC to the base BC plus, this is already log of A to the base BC. Similarly, in the next one, it is 1 divided by. This one, because of this CA, can be written as log of CA to the base CA plus log of B to the base CA. Similarly, in the third one, this one in denominator, because of this AB, can be written as log of AB to the base AB plus log of C to the base AB. Now see what happens. 1 divided by. In the first one, here it is log BC to the base BC, here it is plus log A to the base BC. BC, bases are same. So the numbers get multiplied. So it is BC into A, which becomes ABC. So we have log ABC to the base BC. Similarly, in the second one, 1 divided by. Bases are same, CA and CA. So it is log base CA and the numbers inside get multiplied. So it is CA into B, that is again ABC. In the third one, we have 1 divided by. You see, it is log AB to the base AB plus C to the base AB. So AB base same. So log of AB base, and your AB into C plus sign means numbers get multiplied. So it becomes ABC. Alright. Now we apply this rule. Log A to the base B is equal to 1 by log B to the base A. That means 1 by log B to the base A, when it goes in numerator, it becomes log A to the base B. So the number and the base get interchanged. So the first one becomes log BC to the base ABC. The second one becomes log CA to the base ABC. Plus the third one becomes log AB to the base ABC. Now you see, these are the 3 logs to be added and all of them have the same base ABC. So the numbers inside, that is BC, CA and AB, will get multiplied. So what do we get from here? We get log AB into BC into CA to the base ABC. Now what is ABC? What is AB into BC into CA? You see, it is A square, B square, C square, which can be written as log of ABC square to the base ABC. Alright. Now this 2 comes out and we have 2 times log ABC to the base ABC. Now 2 times this log ABC to the base ABC must become 1. So the final answer of the question is 2. So it's a long question, but it's an interesting one. Don't worry. It is just for the sake of practice that I have given this question. Note it down carefully. Now the last rule, rule 4. This is a very interesting rule. I'll directly give you the rule. Suppose we have a to the power log b to the base c. Please read it very carefully. The power itself is a log, right? In this, what we can do is we can interchange this a and this b without affecting the position of c. Look at the position of a. A is the base of the power here. B is the number in the log and c is the base of log. C cannot be changed. This a and b, if you interchange, it will become b to the power log a to the base c. These two are equal. This is the last rule. This is rule 4. Right? So if there is a question which says 7 to the power log of 625 to the base 49, and the question says simplify, what you can do is you can interchange this 7 and 625, so it will become 625 to the power log of 7 to the base 49. Make sure that the position of 49 is not touched, is not changed at all, is not affected at all. Now this becomes 625, and here this is 7 raised to 1 and this is 7 raised to 2. So I can write it as 7, a log of 7 to the base 7 square. So this one becomes 625 to the power. From here, this 2 comes out in denominator, so it becomes 1 by 2 log 7 to the base 7. Now, so log 7 to the base 7 has to become 1. So this becomes 1 by 2. So we have 625 to the power 1 by 2. That is square root of 625. And we all know 625 is the square of 25. So square root of 625 will be 25. So the final answer of this question is 25. So this is one very peculiar specific rule related to log. Alright. Now, please understand that any question in any exam, be it a big exam, be it a small exam, questions related to logs have to be related to one of these rules only. Alright. There is no other rule possible.